discussion currently. Fei, please stick around. I think you're also part of the panel. Now, the multimodal example so far has been quite interesting. So we started with language models, and now we're talking about vision and language models, multimodality, and we also put the twist of robotics here, which brings in a whole host of additional questions. For example, with language models, we get human data to somehow make the language models perform a little bit and also align with us a little bit. And for the question that Neil had, which I thought was quite good, that we can also think about human demonstrations in the reinforcement learning sense for these multimodal models. Let me ask the panel members, what do you think about where the boundaries are now? Because this seems to be quite interesting, because you can now do the tests with demonstrations, you can converse with these agents. Are we getting to AGI kind of domain now? What do you think? I mean, do you have any dream in this setting that you think you can accomplish in your maybe next 10 years? Anything you would like to share? Or was it too much?
Well, I'm not sure about 10 years, but okay, so something that's, it's clearly working well now to add these capabilities, like visual capabilities, like actions, to these models, kind of after the fact, right? You train your language model, you add in these extra modalities, and it works with these extra modalities and quite nicely. But I don't think it's been shown yet, and I'm sure some research can be done, is to add these modalities at the start and greatly accelerate the learning of the language model in the first place. But at the moment, if you add these modalities at the start, maybe it doesn't hurt, and you get some extra capabilities, but it would be, I think the dream would be to see you've got 100x faster learning of sort of general language capabilities and cognitive capabilities through having also trained to align with images, actions, and whatnot. I think that's a pretty interesting challenge, and something for the next few years.
I think my dream is a bit, I would say, less, not calibrated, but I would say slightly more muted than Ian's vision. I think we have, sort of truly general purpose systems in language, but vision is lacking behind, as I spoke in my talk. And I think robotics is even more behind, right? So I think the next frontiers for multimodality are to sort of get towards the capabilities of large language models in the vision and action space. And I think that would be a tremendous accomplishment, because the amount of data that we have to process is a lot more in terms of bytes, right? And so more advances are going to be required in order to get us there. I think another way of thinking about these multimodal systems is, do we need to train everything together, or is the language part of these models the right space to sort of perform reasoning, and are there separate parameters where you have to sort of do parsing and production? The work that we just saw in the talk here, gets the language model to do a lot of the planning. And so, should multimodal models be built that way, or should they truly be multimodal from the ground up? I think that is an exciting line of research.
10 years is a long time, so I made pivots in 6 months, so I don't know. But if I take 10 years back and what I was working on and what is working and what's working now, 10 years ago it was LLMs, features, and so on, and I look now, it's basically the same, just much better. So if I think of multimodality, I think actually for me the biggest blocker so far is I haven't seen really a benchmark that really convinced me that we are doing something there. We do VQA, which is, in my opinion, a relatively weird task. We do captioning or things like that, but nothing that, this is really where multimodality is going to be a killer app. I think maybe robotics, but I really don't know. anything about robotics, so that's out of my field of expertise. But the things I know, I feel that this has been the biggest challenge that we haven't resolved in 10 years and still haven't resolved yet. So my hope is that we figure out finally, and maybe this will come thanks to some technology, maybe VR or whatever, that suddenly, oh, now there's a real problem that we can really benchmark and make very fast progress. So for me, that's the one thing I really want to see.
Fantastic. The history repeats itself, but hopefully things get better somehow. Fei, would you like to?
Yeah, I can comment on that. So first, we usually don't mix robotics and killer app as two words together. So I don't know what a good application is. So regarding like 10 years timeline, I think we will see a merge of all different multimodals into like language models. Soon there will be no boundary between language model and multimodal models. Like they're just taking like different tokens, but hopefully they have the same capability or generality as language models, right? So in language models currently you can prompt it, you can do instruction following and all these sorts of things, but we yet to see those, let's say, instruction following or reasoning emerge in multimodal models, right? So can you do like instruction following or reasoning with multimodal models? So that I think is what I'm most excited about. That's it.
Sorry, I got distracted. Thank you for this answer. But so I think Armand has also made an interesting point. So in the end, we are. So during these 2 days, we've seen these scaling laws, for example. And I think Julien mentioned that the scaling laws for the multimodal models is completely unclear. Anybody want to add to this? Because it seems that, okay, so we just take the internet token size, let's say we have 40 trillion tokens, right? But when it comes down to video, I don't know, is there a limit to tokens? Now we would like to build truly multimodal models and that we would like to train them somehow. I mean, I can imagine maybe another triply exponential scaling law appearing in terms of compute and so on and so forth. Do you think there are some extenuating circumstances in terms of economizing on the compute for these multimodal models, or is this going to be some sort of challenge that we should think about? I mean, do you think things will continue as usual?
I think things will continue for a while as usual until one hits some new bottleneck, like how much compute it's possible to co-locate in one data center or so. With respect to multimodal scaling laws, I'd say that's a bit sort of what I was referring to when I was saying, at the moment, multimodal training hasn't unlocked, a new paradigm of scaling for language models, but it also depends a bit what you want to do with it. Right? If you want to do video generation, okay, then you want to, then all these video tokens will be incredibly useful. When it comes to pure language modeling, it's not so clear at the moment. So, when things like video generation start working well, then there'll be another set of scaling laws that requires a vast number of video tokens. This probably, could go even further, provided one doesn't get bottlenecked somewhere else, like data center size or.
I would also add that, so maybe I'm wrong here, but I feel that still scaling laws are still relatively poorly understood, even in the realm, like much smaller airlines, like Chinchilla, for example, is barely a year old, maybe, a little more than a year old, and there was already a big change in how they were perceived and so on. I think in vision there is a few works, a few companies book actually on scaling law that start to understand a little bit things are going. But it's not, they see questions appearing. And they train 22 billion vision models. We barely have the first data points in that space. So I think we are really, and that's easy, simple case, like just images, just text. So I feel that we still have a lot of ground to beginning of conclusion and scaling in multimodality.
I think there's a difference to language as well. I think a lot of works in language have sort of converged upon, we're currently in let's say some sort of a local minimum, right? So we've found a paradigm of training that seems to work really well. Of course, there's going to be better paradigms in the future, but right now we've all settled upon this, and so works coming out of different universities, different companies, etc., can all go onto the same scaling law plot. Whereas if you look at vision and language models, every team's model is architected quite differently, and I think there's a maybe it takes 6 months, maybe it takes a year, but it's going to take some convergence before we start thinking about this problem. I think so we're a bit far away from it.
Yes, Armand mentioned something like if you would like to innovate, it takes 10 times more compute.
Yeah, I mean, that's don't quote me on that number.
I don't know forever, but that number. But so, I mean, I guess for the multimodal, there is now some sort of a clutch architecture that works for the multimodal models, and that in this exploratory space, maybe we are not even in a local minimum, but somehow in some sort of a descent.
Yeah, I mean the 10x number isn't out of the realm of possibility, right? Like you do need 10x compute to do a lot of innovation. And so one way to do that in the multimodal space is to say, can we start exploring models where we sort of use a frozen language model, let's say now again, right? It's open source, we can use it, and then how can we build adapters efficiently? At least that makes research a lot more accessible. And I suspect that there's, if you go on archive in the last 6 months, there's already a big bunch of papers that are doing exactly this. So we might see a convergence of adapter architectures, and at least in that space we can start studying scaling laws.
Awesome. Fei, would you like to add anything on this?
Yeah, I think scaling law in the era of multimodal models is even more interesting. Like so far, we have been studying scaling law in one modality, right? So there's scaling law in text and the scaling law in vision. But when you have multimodal modality, you can think about some joint scaling law, which I think will be truly fascinating. Like, can you increase your amount of text training data to improve the vision understanding performance, or can you increase the let's say visual focus and then it improve text perplexity? So I think that would be truly intriguing. Like, what is the real composition of those? And these are just a few modalities. There are even more. There are audio. There are robot actions. So it's quite interesting. So we start to look this into a little bit in RT2, right? So when we fine tuning on robot data, we can actually study the amount of pre-training data, like how to do with downstream tasks. But I think there are more to explore when you talk about multimodal scaling law. That's it.
If I can add also something which is like to get these scaling laws, or to get in one modality or two modality things. As you were saying before, like we need some of convergence to enable them. And like what's remarkable, I think, in AI, and what I really love, is usually the most simple stuff that works the best because they scale, and that's usually simplicity is the key. Like LLMs, like if you think of it, is such a dumb problem, and what we are doing is so simple. Like saying in vision where you supervise. VIT is so simple, like you just transform your plate, and that's the beauty. And simplicity is hard, especially when you are multimodality. Like it's extremely hard to find the thing that is simple is going to work. And before we achieve that moment in multimodality, like where you don't need to take one model and another adapter and so on. And I think that's like what's going to help figuring out the space of what's possible and so on and so on. But you need to go through that space where you kind of pipeline-ish stuff, get to the moment where the performance are getting good, and then we need to have that phase where we simplify everything and say, oh, that's the architecture network, that's the thing, and then we can start scaling and all that. I think the whole process takes time, and I'm not sure it's going to happen like that. Maybe things are moving so fast.
You make great points. I just would like to make two remarks. One, of course, we expect super modular kind of behavior when we put together video and audio. I mean, just think about silent cinema and cinema with the audio and the text that you get. You gain so much from it. The other point that I want to make, I'm glad that you're calling things like transforming simple. I think that in retrospect they are. So hopefully we will have some simplifying innovations to this round that will make us, somehow enable us to have these capabilities without.
And just to make it simple is hard and it's good. And as opposed to what most reviewers say, it's the thing that is the hardest to achieve. Again, if I take transformism, I think for me one of my favorite examples is Vita. When you think of it, it's just applying transformer to images. How simple is that? But you see what happens after that. So that's this type of things where the idea just fits in a very simple, line, and so on are usually the best, and they are the hardest to make work.
I think we're in the same cluster when we talk about video tools.
Yes.
For sure. Anybody else want to add to anything on this?
Yes, so simple is for sure important, but I think it's also important it is general. One can imagine sort of almost any task that one formulated text being formulated as a sort of left or right language modeling task. So you can imagine it sort of subsumed everything. And I think this is maybe what we're missing in computer vision, which is why I'm not fully converted how to measure scaling models there, is that there's a bit of a wild west of different losses, and with the bit which you've been relatively recently referred to training today, we'll probably use a slightly different loss, and a lot of the really great vision work from Meta, often based around sort of mask style visual losses, and this works really well for detection and localization, and then at Google we're a bit more doing the sort of image text stuff, which maybe is a bit more VQA focused. And so there's not this so there's a few simple things, but they all have blind spots in the moment. So it's not, pixel by pixel generation is somehow fully general, but it doesn't yet work out well.
I completely agree with what Hassan just said. I think people don't realize how beautiful is the language modeling loss. How simple it is, it's classified, you predict, you generalize, everything is in that loss. It's just a perfect problem. And in vision we don't have it. The main reason why I started working on SSL a few years back, it was just before that I was working on world representation in large language model, and I was what's the equivalent of that in vision? And I worked on that problem for 6 years or something. I haven't figured it out. All the losses I came up with are just not crap, but I don't think they are what we need. And that's just for images. There has to be something similar, maybe, but so far we haven't found it.
That is great. For language models, the classification paradigm works well, but vision seems to take it to some higher dimensions that we don't know. So I think it should be given the time we try to wrap down, but I think Amir has a question.
Do you take questions from the audience? Or?
I think we can use the last 5 minutes to take questions from the audience. I think it's a good idea.
I will start with one. Cool. So maybe shifting gears a little bit. So I'm curious about your perspective. So when I look at talks yesterday and today, when it comes to unifying language with other modalities, so we see a number of approaches being employed. So I think the older one was that, let's say, in vision and language, it was fairly common to train one model with vision, with language, and with this sort of captioning, I guess, was the most standard way. In this way, language and vision are kind of learned completely in a blended way. Now, if you look at yesterday and today, after the rise of language models, there are a lot of works that basically use language model as a parser, as a planner. That was not trained, co-trained because of these other modalities, like on these like visual programming. This is an example of that just is used primarily as a parser. In Fei's IP work also very much was in that area that the language model is used as a high-level planner, and there's low-level modules that execute that. And also there's a lot of API-like development. So there's probably one of the biggest crazes that how people can develop businesses and startups, APIs that sit on top of. So it's almost like another virtualization layer in programming. So, and this is more new, so I'm curious your perspective. For example, there are like some basic questions that come up. They haven't really exercised this. Like they're not used to kind of plugging these different things together. How much, for example, end-to-end training matters, like in Ani's visual programming? How much did it matter if after you parse, you run it and kind of end-to-end try to? And same for Fei, like when you use the language model, for example, as a parser, you go down, execute the robot might fail, or again, you have a scalar, you have to sort of backprop that sparse signal all the way to the beginning. So generally in this perspective, you have ideas how much one question, for example, end-to-end matter, or other ways to think about this. So I think it depends on the application. I think if you're dealing with high-level semantics, right? So for example, if you want to understand what objects there are and then you want to do some reasoning over that, I think factorizing this out so that you can sort of reason in linguistic space just makes it very efficient, right? And both in Fei's work and in the work that I presented, language model is really a mechanism to manipulate symbols once you have recognized things from your observations. And I think that works really well. I think end-to-end models are needed once you start doing low-level manipulation, right? If you want to have a robot open a door and you have to simultaneously navigate and manipulate, then I think factorizing this out into language model space, I don't think that's going to work really well. And so whatever the equivalent is in the vision side, where you need very close coupling of visual parsing and reasoning, I think that's where we need end-to-end models.
Fei, would you like to add any comments?
Yeah, if I may, I would like to add 2 points. So first, I think I agree that it's like application dependent, and it's depending on, so when you're using API, you're limiting everything to a language interface. And language is not a super high bandwidth interface. So it depends if you can factorize your problem so that you can, it can be, different modules can communicate through a low bandwidth interface. So if that's possible, then using the language model as a high-level planner seems good enough. However, if there's more nuance, and then you need to continuously model actions and images, then probably training end-to-end is better. So I would like to say that RT2 is actually that way. So you have a more richer, high-bandwidth interface between language model and other modalities. The other thing that I want to mention is when you're using language model as a high-level planner and communicating everything through language, it actually generalizes differently. So an end-to-end training model, when you truly fuse all different modalities together, you expect to see more generalization and different generalization behavior. It's an intuition. It needs to be probably benchmarked thoroughly, but it might generalize it differently. You will see different compositional generalization between or among different modalities. So I think that's another benefit of end-to-end training. Sometimes you need those, sometimes you don't. That's it.
Yeah, and also like just to be clear, when I say end-to-end, I think that's an opportunity even for language modeling space. End-to-end,
I mean, like think about it this way. Let's say we use language model as a planner, and it fails, right? There are some nuances in the physical aspect of executing a class and it fails. And once you go all the way down, how do we actually pass the feedback that, oh, your language model, your planner, but between these two like seemingly equal plans. One of them was better than the other. So in end-to-end, I don't mean getting rid of the language model, getting rid of the modularity, but somehow link back the physical knowledge that is probably in the sensor system and the execution that are not well reflected in the open loop language training, somehow back into it. So yeah, but by end-to-end, I don't mean like, for example, going into like an instruct, so it's like a case-to-case model that everything has to be channeled through language, but no like parsing the specific explicit like that. So just as a clarification.
All right. Any other quick questions? I think we should try to wrap up.
I have one.
So I know the topic here is foundation models, but we are in the applied machine learning days, so there's more than foundation models at our disposal. So it's a big community that's work on neural symbolic AI, trying to bring rules, symbols into the picture, because I mean I use always the same metaphor. Show and run the rules of the road by just watching a lot of videos and trying to teach deep neural network. That's not very efficient because I can give you the book. 30 pages and you know the rules of the road, right? So how do you see when these things will start to merge together? Are we running out of possibilities just pushing foundation models and LLMs this way alone? And when is the symbolic part going to become important for you?
Well, if you start building architectures that leverage language models and then build parsers on top for visual modalities, you kind of think of this philosophically as neurosymbolic approaches. You can think of your visual parser as your neural network, and then your language model as, I'm kind of stretching this definition here, but you can think of reasoning in language space as manipulating symbols. And your example of the traffic rules is a great example, because if you asked a vision language model that was built on top of a frozen model like Llama 2, you showed it a sign and said, "Can I cross the road here?" And let's say it had a red person there. It would probably say, "No, you should cross the road because the pedestrian traffic light says red." So language models have the ability to learn a lot of world knowledge a lot more efficiently than if you had to parse out like 10,000 videos of people crossing the road and not crossing the road, right? And then the visual model is basically acting as your neural network that parses out from the observations. So I would say adapters built on top of language models are sort of going in the direction that you've mentioned.
Maybe another sort of, not so precise, but somewhat philosophically similar sort of touch point between these two methods is through tool use, where you can sort of execute sort of deterministic and precise computation through your tool, and then do this like soft computation on top through the language model. So that's where you can get hold of Wolfram Alpha or Python interpreter and do the kind of computation that symbolic computation is good at. And then the language model can make use of that as it sees fit.
I also like that one thing. I mean, I wish when we train models, there are certain parts that are interpretable, that we can assign that it is doing this function, just driving, for example. In that case, it's like you take that part of the neural network and replace it with like a decision tree that comes from your manual, and the inference will be faster, everything will be faster. But currently, I don't see a clear interpretable part of the neural network for a particular task. I think it's a generalistic approach to language, which makes it very powerful at the same time, somehow makes it a little bit less amenable to this rule-based compute. I think if you can combine the two, that's like a winning strategy, of course. That's a very good point, in my opinion. Fei, do you have any remarks?
Yeah, one thing that I want to mention. So it's one way of doing like neurosymbolic, but I don't think it's the best way. One way to do it, and we have tried it before, is guided decoding or constraint decoding. So sometimes you want the flexibility of the language model, but sometimes you also just wanted to choose between, let's say, multiple choice answers, right? So here you can have constrained decoding, or you wanted to choose only the possible robot actions here. So here you can also use constrained decoding or scoring mode. So I think flexible decoding mechanism and flexible way of guiding the language model is yet another way to do like this neural symbolic computation.
All right, on that bombshell, let's end the session. So let's thank the speakers, the organizers, and the AMLD staff that is helping us. Thanks for coming to our session. Have a great evening.